YouTube channel. In this video lecture, I am going to answer question 21 to question 30 from DME chapter Keith Williams Radio Lab. So let's start with question number 21. Distance measuring equipment uses radar principles to measure what kind of distance. So always remember, all DME indications are slant range distances. Meaning, let's say this is your aircraft. If this is your aircraft and there is a DME station on the ground, the indication given by the DME will be slant range indication. It will be slant range indication. Whereas horizontal distance is this. This is the horizontal range. But you won't get horizontal range directly. You will be given slant range, horizontal. Now there will be some numericals in which you will have to calculate horizontal range or slant range using Pythagoras theorem. We have solved that. There are many such questions as we go forward. So over here the answer will be option Charlie. DME uses radar principles to measure slant range. Question 22. ICAO specifications are that range errors indicated by DME equipment should not exceed what value? So they are talking about accuracy limit of the distance measuring equipment. It is always plus minus 0.25 nautical miles plus 1.25 percentage of the distance you are from the DME stations. Let's say you are 100 nautical miles away from the DME station. So plus minus 0.25 nautical miles plus 1.25% of 100 nautical miles. Whatever distance is measured in the question, you have to calculate the percentage value of that particular distance. So correct option here will be option Bravo. Plus minus 0.25 miles plus 1.25% of the distance measured. Okay. Next. What is the maximum distance between VOR and DME ground installations if they are to have the same Morse code identifier? So very important table given in the Oxford. First, the table begins with the first column headed relative positions of VOR DME or TACAN facility. The second column frequency, the third column Morse code identification. So now a DME and a VOR station will be considered to be co-located, okay, if they fulfill one of these three conditions. First conditions, both transmitters, VOR station, DME station co-located, means they are existing, means they exist at the same location. Second condition, the maximum distance between VOR transmitter and DME ground transmitter is 30 meter. 30 meter is nothing but 100 feet in terminal area. Okay, terminal area is the transition airspace between your aerodrome traffic area or aerodrome traffic area and area control. Okay, so terminal area is where there will be many airways, confluence or intersection of many airways which help in transitioning aircraft from takeoff phase to cruise phase and bringing aircraft back from cruise phase to airport, the airport airspace or aerodrome airspace or aerodrome traffic zone. So terminal area is a very busy airspace. So the maximum distance between both transmitters is 30 meter or 100 feet maximum. Third condition is the maximum distance between both transmitters is 600 meter, which translates to 2000 feet for use elsewhere. So anywhere else, anywhere other than terminal area, the maximum distance between a VOR station and a DME station can be 2000 feet. Okay, if it exceeds 2000 feet, VOR station and the DME station won't be considered to be co-located. Okay, so in all these three conditions, the frequencies will be paired. Okay, so if you select VOR frequency, automatically DME frequency or DME will automatically get switched on. Identification very important. Both transmit the same call sign. Both VOR station and the DME station transmit the same call sign. 3 or 4 idents. There are 4 identifications you will hear every 30 seconds. The first 3 identifications or the first 3 idents that you hear belong to the VOR station, and the last ident that you will hear will belong to the DME station. So 4 idents, first 3 VOR, the last one DME, and this will happen for 30 seconds. Okay, so the correct answer here will be, what is the maximum distance between VOR DME if they are to have the same Morse code identifier? So it is 600 meter or 2000 feet outside the terminal area. Outside terminal area. Next, 24. A DME in tracking mode. That means it is in tracking mode. That means it has achieved successfully achieved a lock on, meaning it is successfully getting a DME indication in the cockpit. It experiences a reduction in signal strength. So uh, it was achieving a successful, it has achieved a successful lock on, and it was getting DME indications represented in the cockpit. But due to some reason, that is reduction in signal strength, now it has lost its lock on, okay, with the DME station. So when it loses a lock on with the DME station, that means it loses the connection between the DME station and itself. What happens to the DME airborne equipment? So it switches to memory mode. First instance, meaning the first, whenever it loses the lock on or the successful connection between the ground station or ground DME station and the airborne receiver, it will automatically switch to the memory mode. What is memory mode? Memory mode is that mode when the DME will continue, DME receiver in aircraft continue to show slant range information, that is DME slant range, nothing but DME range on the display. So whatever the DME range was before the DME receiver lost its lock-on facility, it will continue to show that previous value, whatever that value was, for some time. In older DME equipments, it is for 10 seconds. In modern equipment, it can be more than that. So in the first instance, it will switch to memory mode for those 10-20 seconds. Okay, and in those after that, after memory mode, it will switch to search mode. So the second step is switching to search mode. Okay, so if during those 10-20 seconds of memory mode, the DME receiver is unable to achieve a successful lock on again, it will switch back to search mode. In that search mode, it will start searching for any DME station around itself, with which it can connect with, and start showing DME slant range from that particular station. So remember this question, very important. Okay. Next, question 25. Of what use is a military TACAN station to civil aviation? Remember civil aviation. So TACAN is nothing but tactical air navigation, mainly used by military tactical air navigation. Now this TACAN facility can use a DME station, can use a DME ground station to give slant range information, just like a normal DME station. Slant range information. But along with this slant range information, it also gives bearing information, just like a VOR. Like a VOR, meaning it will tell the bearing at which aircraft is situated with respect to this TACAN facility, the radial on which it is situated, like VOR. Okay, but there is a trick here. This bearing facility or this bearing information can only be interpreted by military aircraft. Civil aircraft or civil airborne equipments do not have that facility to interpret or decode this bearing information. So the civil aircraft can only use slant range information. Can only use the slant range information. So the correct option here is, it can provide DME distance only. DME that has difficulty obtaining a lock on, what will it do? So that means it is not able to achieve a lock on or have a connection with a DME station on the ground. What will it do? So there is a procedure that you must remember to achieve a lock on. So that procedure is that first the DME receiver in your aircraft will begin a search mode. This search mode, it will search the nearest DME station, achieve lock on. In this step 1, that is search mode, it will transmit 150 pulse pair per second. 150 pulse pairs per second. Step number 2. If it is unable to achieve a lock on, in 100 seconds, it will slow down its search rate at 60 pulse pair per second. Okay, so this is very important. Third, after achieving a lock on, the scan rate becomes 25 to 30 pulses, 25 to 30 pulse per second, per second. So now that has difficulty obtaining a lock on, stays in search mode without a reduction in PRF, wrong. There will be a reduction in PRF. 150 will become 60, right? So stays in search mode but reduces PRF, pulse recurrence frequency, to maximum 60 after 100 seconds. Yes. So after 100 seconds, the PRF becomes 60. Alternates search mode with periods of memory mode, wrong. Stays in search mode but reduces pulse recurrence frequency to 60 pulses per second after 1500 pulse pairs have been transmitted. Okay, so the correct option here will be option bravo. Question 27. DME channels utilize frequencies of approximately 1000 megahertz. So DME frequency band is 962 megahertz, 960 approximately to 1213 megahertz. So on an average 1000 megahertz is the frequency. So correct option is option alpha. Question 28. A VOR and DME are co-located. You want to identify the DME by listening to the call sign. Having heard the same call sign 4 times in 30 seconds, which one of the which one of those which one of the identification will belong to the DME? Will the first identification, you will hear total 4 identities. Will the first one belong to DME, the second one, or the third one, or the fourth one? So very important. Just now I showed you this diagram that 4 identifications. There are 4 idents every 30 seconds. So the first three will belong to VOR. The last one will belong to DME, and the one belonging to DME will have a higher pitch tone. So that is how you separate, or that is how you distinguish between VOR and DME. So the one with the DME will be a higher pitch tone. So question 28. DME call sign, delta is the right answer. DME call sign is the one with the higher pitch that was broadcast only once, that is only one type out of total of 4 types. Question 29. Which one is the most correct? Most correct. So there may be other correct statements. So you have to identify the most correct regarding the range of the DME. So operates on the principle of phase comparison, wrong. Phase comparison is VOR, not DME. Range within line of sight and maximum 200, yes. All DME systems, all DME range depend on the line of sight principle. Your aircraft must be within a particular height, altitude and a range in order to get or achieve DME lock on. Operates on VHF, wrong. DME operates on UHF. Has unlimited range due to ground wave propagation, that is also wrong. It has a limited range of 200 miles maximum. Next, question 30. The indicated range from a DME is slant range. It is slant range, very important. So slant range means, let's say if this is your aircraft, here is your aircraft, there is a ground station, DME station here. So the slant range will be this. Okay. And ground horizontal range will be this, the flat horizontal ground range. Next, so this concludes our lecture. I hope you have understood all these 10 questions, the answers and explanations. Keep studying, keep working hard, keep practicing. The more you practice, the more confident and proficient you become. Please share this video with your friends who are also preparing for this exam, and hit the like button if you have liked this video lecture. All the best, and don't miss my next video in which I will continue solving the next 10 questions remaining. So I'll see you